Thank you for viewing this presentation, where I will explore some specific ways to reduce the carbon footprint of your data center and provide you with some key actions that you can take as you navigate your data center sustainability journey. My name is Brian Peters, and I'm a Senior Director at Evoqua Water Technologies, where I lead the disinfection business in North and South America. I began my career in water treatment in 1998, and one of the first customers I had the privilege of working with was a data center located in New Jersey. 23 years ago, that data center has some of the same critical needs as we see today, such as security and the need for redundancy to ensure the servers do not come down unexpectedly. And while they were conscious of the amount of water they used, we didn't talk about the carbon impact of the data center, which of course is a common discussion we have today. When I hear people talk about sustainability, they usually have separate conversations around water usage and the carbon footprint of the facility. But for today's presentation, I'm going to examine a specific relationship that water and carbon production have to one another. Before I do that, I'd like to introduce you to Evoqua Water Technologies. We are a leading provider of water and wastewater treatment solutions. We offer a broad portfolio of products, services, and expertise to support industrial, municipal, and recreational customers. At Evoqua, we are proud of the work we do in transforming water and enriching life. And we believe that it is only possible by combining expertise, innovation, and a commitment to supporting our customers in using this precious resource responsibly, efficiently, and ultimately sustainably. Using water is a very efficient way to remove heat from the server rooms, and it has been a common way of doing so for many years. But using water does come with some challenges that I think are important to understand. The cooling tower pictured in the center of this slide is what allows the transfer of heat from the server room to the atmosphere. This process is commonly referred to as evaporative cooling, which in its own right is a sustainable process. The water that has absorbed the heat from the servers enters at the top of the cooling tower, and it falls to the bottom as air is circulated across the water, allowing a portion of the water to evaporate. This releases the heat into the atmosphere. The evaporated water eventually rains back to Earth, where it can be used again, and the cooled water that collects at the bottom of the tower can also be used again to bring the heat from the servers back outside to the atmosphere. However, this process contributes to some of the problems that are outlined on this slide. Water can cause corrosion, fouling, scaling, and microbiological growth. And each individual issue can exacerbate or accelerate the other three. The important thing to note is that when any of these problems manifest themselves, you are not using your water responsibly. These problems can cause you more energy by reducing heat transfer. It can cause you to use more water due to leaks. And more importantly, it can provide an unsafe environment. Typically, these challenges are solved with a robust chemical program that consists of antiscalants, corrosions, inhibitors, and biocides. I'd like to focus in on these chemicals and see if we can't leverage technologies to reduce the amount of chemicals needed, which will reduce the carbon footprint and provide a safer work environment. Liquid-based chemical formulations are often made with low percentage of active ingredients. The main reason for this is because as the active ingredients become more concentrated in a liquid formulation, they become unstable. I'd like to highlight one of the more common chemicals used to disinfect cooling water, which is sodium hypochlorite, otherwise known as bleach. Now, this biocide is referred to as an oxidizing biocide, and it is a very effective biocide. In fact, the Cooling Tower Institute recommends maintaining your residual of oxidizing biocide in your cooling water, just like you might do in a swimming pool. This is to reduce the risks associated with bacteria and biofilms, most notably Legionnaire's disease. This chemical is typically delivered in a 12.5% concentration. But the concentration will degrade over time. So the average concentration is closer to about 10.5%. Now, a 55-gallon drum of sodium hypochlorite weighs about 500 pounds. And of that 500 pounds, roughly 437 is water. So what this means is that you're transporting 55 gallons of a product to get less than 7 gallons of the active ingredient that is helping to disinfect your water. I hope you can see that this is not a good equation when it comes to a relationship of carbon produced to transport the active portion of this chemical. Now, one way to improve this equation is to generate the sodium hypochlorite at your data center. And you can do this via Evoqua's OSEC system. OSEC stands for on-site electrochlorination. OSEC works by converting a brine solution that is made from water and salt. The brine solution is pumped through an electrolytic cell, which converts the brine into a low concentration of chlorine, roughly a 0.8% concentration. So instead of transporting the water on a truck that has a carbon footprint, you use the water that comes out of the tap. Now, you might say, but don't I still have to ship salt to my facility? And the answer would be yes. But let's examine the overall carbon impact between the two options. As I mentioned, 12.5% sodium hypochlorite degrades. So for this example, I assumed that over the life of the drum, the average concentration would be 10.5%. What that means is that 500-pound drum will be able to provide roughly 52 pounds of chlorine to the system. Now, 500 pounds of salt via Evoqua's OSEC system has the ability to deliver 161 pounds of chlorine to the system. So for the same carbon creation related to just the transportation of these two supplies, the salt via the OSEC system provides 3 times the disinfection capability. Now, large-scale data centers can use thousands of gallons of bleach in a year. So by choosing to make the disinfection on site, you can make a big impact to reducing your carbon footprint. It will also reduce the risks associated with transportation and handling of a hazardous chemical. As the chlorine manufactured out of the OSEC system is only 0.8% and not considered hazardous. So now that we've established the relationship of the specialty chemicals used to the carbon impact on your supply chain, let's see how we can further reduce the chemical demand of your cooling system. Now, one of the characteristics of the cooling tower is that it allows airborne particulate to enter the water. This can be dust, pollen, or even insects. These particles become suspended in the water, and the amount of particles in the water is often measured and reported as total suspended solids, or TSS. Suspended solids put a demand on your water treatment chemistry and can lead to you feeding more chemistry than you need. This is because TSS can promote the growth of bacteria and can deposit out in the system, leading to fouling and corrosion issues. I think we've all heard the question, what weighs more, a pound of bricks or a pound of feathers? And of course, they both weigh the same. A similar question is 1 ppm of TSS that consists of 1 3mm sized particle the same as 1 ppm TSS that consists of 256 billion particles that are roughly 2 microns in size? Now, while these are equal to one another in terms of the TSS they provide to the water, from a water treatment perspective, they are very different situations. And you can imagine it is much more challenging to remove the particles in the example to the right. Side stream filtration is an integral part of reducing water used in cooling tower systems. And side stream filtration is again recommended by the Cooling Tower Institute. The only way to truly know what the right filter is in your system is to do a particle size distribution analysis. This analysis is done in a lab and will tell you the size and volume of the suspended solids in your system. Now, I've been involved in many particle size studies, and I'm pretty confident that you will find that nearly 90% of the particles in your cooling tower water are less than 1 micron. Now, most common side stream filters only remove down to 15 microns, allowing everything else to remain in the system. But as you can see by this slide, Evoqua's water sand filter can remove down to 0.5 microns. This filter can potentially remove over 90% of the particles found in your cooling water, greatly reducing your chemical demand. Now, while I only highlighted 2 of Evoqua's technologies that can reduce the amount of chemicals needed to treat your cooling water system, we have other sustainable solutions, such as ozone and UV, that could potentially eliminate the delivery of certain consumable chemistries altogether. We also have a platform of monitoring and control devices to ensure that the reduction of chemistry doesn't mean a reduction in performance. I hope I was able to provide some key actions that you can take in reducing the amount of chemicals needed to protect your cooling water system, which will improve system performance and efficiencies, leading to lower operating costs, but perhaps more importantly, help reduce health and safety risks attributed to the transportation and storage of hazardous chemicals. Thank you for spending some time with me. Please go to Evoqua.com to learn more about our offerings. I encourage you to click on the Contact Us icon to connect with a local team member, and together we can transform your water and enrich life. Have a wonderful day.